Question 22 is asking about definitions, the difference between a census and sampling. And these definitions are in section 1.3. A census is when we can measure the entire population. It's usually very difficult and costly. And a sampling then is when we just measure part of the population. It's much more common because it's much more efficient. Another definition for 23. What is replication? It is the repetition of an experiment under the same or similar conditions. And that's important because if we can get the same results under the same or similar conditions, it helps to enhance the validity of the results. And on page 20, you can find the definition of replication and read more about it there. Number 24 is a definition about the different types of sampling. And just make sure that the type of sampling mentioned lines up exactly with the definition given. This one says stratified sampling, but the definition here is actually for systematic sampling. And page 23 talks about systematic sampling. And then back on page 22, you can see about stratified and cluster sampling. 25 is about the definitions of an observational study and an experiment. And with an observational study, we're just observing. We're trying not to have any interaction or any influence on what we're seeing. But with an experiment, we set up some sort of study. We're applying a treatment, doing something, and then observing what the response is. And right at the beginning of this section is where you can find the definitions of observational studies and experiments. Number 26, we have a scenario, and we need to first decide what type of sampling is occurring, and then discuss if there's any bias or not. So refer back to the definitions to decide if it's stratified sample, a cluster sample, systematic sample, and so on. In this example, we're asking every 16th person. That's how systematic sampling works. And then the second half of the question is about what could possibly be a bias or influence the results in any way. And so think about the options given and choose anything that could influence the results of the sample. So 27, moved on to chapter 2.1 here. Start with what are some of the benefits of representing data sets using frequency distributions. And these are discussed right at the beginning of 2.1. And one of the main benefits of frequency distributions is that as opposed to just having raw data, a bunch of numbers, it's difficult to see patterns. When you arrange the data in a frequency distribution, it can be easier for those patterns to be clear and evident, and you just spot what's going on with the data. And the same is actually true for the graphs of frequency distributions. When you graph it, it also makes it easier then to identify patterns of the data set by looking at the graph and seeing that visual image of those numbers in the data. 28 is asking about two definitions, relative frequency and cumulative frequency. And these are found on page 42. You can read the definitions of each right here. 29, a definition, what is an ogive? And an ogive is a graph that displays cumulative frequencies. Page 46 talks about them at the bottom, and then more on page 47 as well. In 30, we have a frequency distribution, and we're going to create an expanded frequency distribution. And so here we have the same classes that were listed up here vertically now, the same frequencies that were listed here. And then first the midpoint. So 17 to 27 is a total of 10. All of these classes have a total of 10. So half of that would be 5. So 5 more than the lower bound would give us the midpoint. So 5 more than 17 is 22. 5 more than 28 is 33, and so on. The point right in the middle. The relative frequency, you're going to look at how many were in each class. So the first class had 18, and then you need to add together all of these values to get the total amount. So for the first relative frequency, it would be 18 divided by that total amount. The second one would be 45 divided by that total amount, and so on. And then cumulative frequency is counting how many data values have been accounted for so far. So after the first class, it's just those 18. After the second class, you've done 18 plus 45, which is a total of 63. After the next class, you've added another 66 in, so it's a total of 129. and so on. And so you can see here from this one that's finished, that total, that what all those add up to, should be 365. Because after we've gone through all the classes, it's showing that we've accounted for 365 data values. Number 31, we have an ogive, which shows cumulative frequency, and our data here is showing the weight of male beagles. And the first question is, what is the cumulative frequency for a weight of 27.5 pounds? So find that weight on the scale here on the x-axis, 27.5. And we go up, we see that the y value there is 40. So the cumulative frequency is 40 for that specific weight. What is the weight for which the cumulative frequency is 45 pounds? So here we want to start by finding 45 on the cumulative frequency axis here, the y-axis, and go over and see where that line, where the ogive crosses it. And then going straight down, we see the weight associated with that is 30.5. How many beagles weigh between 22.5 and 29.5? So it looks like every dot or every dash here is going up by 1. So 22.5 is right after 21.5, and it looks like about 9. And then 29.5 would be 44. So subtracting those two, the number between them is 35. How many beagles weigh more than 30.5 pounds? So at 30.5, we had 45 up to that point, and we end our ogive at a total of 55. So there's 10 more after that point. So 10 would be how many weigh more than 30.5. For 32, you'll be constructing a frequency distribution, and it tells you how many classes to use, using 5 classes. So if you go back to the beginning of section 2.1, there are the steps for constructing a frequency distribution listed. And the first one is to decide on the number of classes. And it told us in this example that we wanted 5. And then to find the class width, we need the range of the data, which is the difference between the largest value and the smallest value. That's the range. And we're going to divide that by the number of classes. In our case, it was 5, and round up to the next convenient number. So our range here, the largest value is 29, the smallest is 0, so 29 minus 0 is 29. Divide that range, divide 29 by 5, and you'll get 5.8 as the answer. So 29 divided by 5 gives us 5.8. We're going to round that up to 6 as the width of our class. Then each class is going to have a lower and upper limit. We're going to find those. We start by listing the minimum data entry can be the lower limit of the first class. So in our example, 0 is the smallest value. 0 will be the lower limit of the first class. And then we add that class width to 0 to get the lower limit of the next class, and then add it again, and so on. So we start with 0 as our first lower limit, add 6 to get our next lower limit, add 6 more, and so on, and you get all the lower limits. And now the upper limits, because the classes cannot overlap, it's going to be the value right below the lower limit of the next class. So since our second class starts with a 6, that first class has to be 0 to 5. Since our third class started with 12, that next class has to be 6 to 11, and so on. And then to create the frequency distribution, you just have to count how many data values fall into each class. It's helpful to make tally marks, so you can keep a track of how many data values you've counted so far in each class. But then once you've counted all of the data, you can list then how many pieces of data fall into each of the different classes. The midpoint is always right in the middle of the lower and upper limit. You can average those values to find what half of them is. So 0 plus 5 is 5. Divide by 2 gives you right in the middle, 2.5. Same here, 6 plus 11 is 17. Divide by 2 would give you 8.5. That's the value right in the middle between 6 and 11. So you get all those midpoints. Now there was a total of 20 pieces of data up here. 4 rows of 5 is 20. So you take 7 divided by 20 gives you the relative frequency for the first class. 4 divided by 20 gives you the relative frequency for the second class. And so on. So how many are in the class divided by the total. And then the cumulative frequency, you're counting how many data values have been accounted for at this point. After the first class, it's 7. After the second class, you've included 4 more, which is a total of 11. And then 3 more is a total of 14, and so on until you've accounted for all 20. And then there's just a few questions down here to analyze your frequency distribution. Here it's asking which class has the greatest frequency to see which number is the largest, and write the lower and upper limit. And then which class has the least frequency, see which number is the smallest, and then write the lower and upper limit of that class. Number 33, we are again creating a frequency distribution to start with, and it tells us the number of classes we're going to use. And so looking at our steps, at the beginning of the section, they're listed here. First, you want to decide on that number of classes, which is 8 for this example problem. And we find the class width by taking the range of the data, the largest value and the smallest value. Largest value subtract the smallest is the range, and divide by the number of classes. In our data here, the largest value is 514, the smallest is 291. So I would want to take 514 minus 291. That gives me the range of the data, and divide by the number of classes. There's 8 of them. That gives me 27.875. To round up to the next convenient number would be 28. So my class width is going to be 28. So now we want to find the class limits, the lower and upper limits. We're going to use the minimum data value as the lower limit of our first class. And so it's 291, that's going to go here. And then we add 28 to that to get the next lower limit. And add 28 more to get the next lower limit, and so on. And once you have all the lower limits, then you want to go back and write in the upper limits. Now, the classes can't overlap, so since the second class started with 319, the first class has to end at 318. And since the third class went all the way to started at 347, the second class has to be 319 to 346. So one less than the class that's coming up after it. And then once you have those, go through your data, cross them out one at a time so you don't forget to count any of them, and just make tally marks in each class for how many data fall into each of the classes. After you've counted through all your data and everything's crossed out, then you can convert the tally marks into actual numbers, and you have your frequency distribution. A frequency histogram just takes those classes, and those go on the x-axis horizontally, and the height of each bar represents the frequency, how much data is in each of the classes. So that first bar should go up to 5, the next bar should be 3 and 2, which you see a downward trend, and then it goes up to 6 and 7 in the middle, and then drops off again to 4, 1, 2. So you should see that pattern of going down, spiking up, and then dropping off again.